Okay, I'm going to explain one of each type of these problems. So find the radius and the measure of arc AB. So this is going to be a distance and this is going to be a degree. So I'm going to draw on a radius. So radius starts at center and goes to the outside, right here. So you want to find the distance of that one red segment. So I know that this is a perpendicular bisector. So these two are equal. So this has to be 12. So then you're going to use 5 squared plus 12 squared equals, we'll call that r squared. So when you do the Pythagorean theorem, you get r equals 13. This is actually a Pythagorean triple. So to find the measure of this arc, what you could do is, we had to figure out the degree right here. So I'm going to draw this triangle right here a little bit bigger. Okay, so this angle right here plus this angle is going to be the measure of the arc. So the blue part. So this part right here corresponds right here. That's half. So what I'm going to do is I'm going to find the angle of this blue angle and I'm going to double it. I'm going to double it, multiply it by 2 because I need this part. So to find this angle, you have a right triangle, so you can use SOHCAHTOA. So you can either use sine, cosine, or tangent because we have all of these sides. So I'm just going to use tangent. So I'm going to do the tangent of angle C in my triangle equals 12 over 5. So remember, when you're trying to find the angle measure, you're going to use inverse. So I do tangent inverse of 12/5. I get that answer and I times it by 2. That's the measure of the arc. So put that in your calculator and multiply it by 2. Make sure you close the parentheses off. Okay, let's try another one over here. So I draw in this radius. So this 6 is going all the way across, so this is 3. So to find the radius, you do 3 squared plus 6 squared equals r squared. So 9 plus 36 equals r squared. R equals the square root of 45. Or to break it down, it would be 3 root 5. So I'm going to I want to find the measure of this arc, or the angle of this arc. So to find the angle of this arc, I'm going to draw this triangle, this right triangle. This is 6, this is 3. I'm trying to find this angle measure. I'll just call it C. So to find that angle measure, I'm going to use tangent again. So I do the tangent of C is 3 over 6, opposite over adjacent. So then to find that angle measure, I'm going to do the tangent inverse of 3, 6. And remember, you're going to have to multiply it by 2 to get the angle measure because this is just half of it, so you multiply it by 2. And then these would be the Pythagorean theorem. 5 squared plus x squared equals 4. This is 4. And then problem number 5, I would draw over a 3 because the radii are all equal. So it's 2 squared plus x squared equals 3 squared, and make sure to double x. And then number 7, if these two are equal, then these two have to be equal as well. So x has to be equal to 3. And number 7, I'm drawing in the radii right here. So you want to know this whole distance across here. So what I would do is I would drop down a 90. This has to be 12. This has to be 60 because it's half of 120. So this angle has to be 60 because this whole thing is 120. So if this is 60 and you know the hypotenuse is 12, you can do a special right triangle to figure out what this side is and this side is, and then you double it. And then number 8 is similar. This has to be 86 degrees because the arc measure is the same thing as the central angle. These two add up to 180. So this has to be 94 or 74. Then you can, this has to be X. You could cut this in half right here. So this one has to be 10. And you can do half of 74 for that angle. So that's 37 degrees. And you have this red triangle that you could use SOHCAHTOA with. So opposite over hypotenuse. So use your angle. So which one would you use for opposite over hypotenuse? You would need to use sine, opposite over hypotenuse. And then number 9, these two are, this is a radius, those two are equal. So you could do 6 squared plus 6 squared equals x squared. Use the Pythagorean theorem. Okay, number 3. If this is 5 and this is 5 and they're perpendicular, if this is bisecting, it's perpendicular. If this is perpendicular, it's bisecting. These two distances have to be the same. Same with this. It goes backwards too. This distance has to equal this. It does. If we know that this is 5 and this is 5, then this distance has to equal this distance. And then number 7, we know that, or number 5, we know that this is equal to this, and this is a 90, this is a 90, so these two have to be equal, which would make this distance 10, 10, 10, 10, so these two have to be 7. And this one, this has to be 25, and these are both 18, 18, so 25, 25, this has to be 50. And then number 8, or 7, this is equal to this, making 90, these two have to be equal, so it has to be 8. And then if this is 5, and this is 5, 3.5 and 90 are bisecting it, then this has to be equal to 10 because all the way across is 10. Okay, so find the measure of arc AB. So if we draw in this triangle, this arc degree is the same thing as this right here. So this is 108. And I could draw the same thing right here. So this also has to be 108. So this has to be 108 as well. So 17 is 108. And then 18 this is an isosceles right triangle. So these two angles have to be 45 degrees. So if I extend this, this angle is 90. Therefore, the measure of arc AB is 90 degrees as well. And then 19, I'm trying to find this degree of this arc, so it's going to be half this angle. So this side is 15, and you're trying to find this angle. And once you find x, you just basically, you have to double x. So if you think about SOHCAHTOA, you're going to use opposite over hypotenuse. So you're going to use sine. So you do the sine of x equals opposite, which is 15, over hypotenuse, which is 17. So then you need to do the inverse. And after you do the inverse, you multiply it by 2 because you need 2 of these right here to equal AB.